Let's say we have to write a program to calculate the zeros of a quadratic equation. If you know your high school algebra, a quadratic equation looks like this: ax square plus bx plus c equal to 0. Now here a is not equal to 0. Then what will be the values of x? Finding the zeros means finding that value of x which will make this equation to be true. So one of the ways in which we can do this is to use the quadratic formula. X is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Now let's look at another method. Let's say we have 2x square plus 7x plus 5 equal to 0. Now what we need to do is multiply these two. So 5 to 10. Now this we have to split it in such a way that sum is equal to this and the product is this. So step by step, if we look at it, 1 times 10, 2 times 5, 5 times 2 and 10 times 1. These are the only options available to us. So now if you look at this, if we add these two, we get 7x and product gives us 10. So which means we can write this as 2x square plus 2x plus 5x plus 5 equal to 0. 2x times x plus 1 plus 5x plus 1 equal to 0. 2x plus 5x plus 1 equal to 0. Or we can say 2x plus 5 equal to 0 or x plus 1 equal to 0. 2x equal to minus 5, x equal to minus 5 by 2. Or we can say minus 2.5, x equal to minus 1. So there are two solutions to this. So this is another method. So this, shall we say, formula method. The other is factorization method, and there are many other methods as well, but this would give you some idea. So let's start off by saying that there are two ways in which we can solve this problem. Now when you are writing code, you generally write it down as to the major steps, and then you keep expanding it. So let's say the steps involved are accepting the values of a, b and c. Step number 1. And a should not be equal to 0. That is the checking we have to do. The second step is, once you have accepted the values, to actually calculate it to what? The zeros, using one of the above algorithms. Then finally display the zeros. Very straightforward, simple 3-step process as far as this problem is concerned. Now one of the ways in which we can write the code is non-object oriented. So the straightforward way is, one, you write main function, public static void main, in whichever language you choose, and you start writing. So you have accept details, then you have calculation steps and display steps, right? Another way is object oriented. Here you actually create an object or define a class quadratic, right? And main function calls the quadratic functions by or after creating an instance of it. Okay, now another method is there, but before that, let's have a look at how such a code would look like. So let's go to this. So this is namespace class quadratic. Int a equal to 0, b equal to 0, c equal to 0, double x1 equal to 0, double x2 equal to 0, boolean no solutions in real equal to false. Then you write except details. Here we are making sure that a's value uh, is greater than 0. Till it is 0, it will keep asking for it. Then display. Now this is the quadratic formula being used to find the roots of the quadratic equation. Okay. Now this is the factorization method. Okay. Now while writing this code, I required a separate function, common factor. So that is there. And then I'm writing the main. So here what's happening? Static void main int choice equal to -1 console.writeLine. Which method to use? Quadratic method or factorization method? And while choice is this, till it is not chosen 0, 1 or 2, choice equal to except. Quadratic q is equal to new quadratic. I'm creating an instance of quadratic q dot accept details, and then depending on the choice that was made, d dot calculate zeros 1, d dot calculate zeros 2. What's the problem with this method? The problem is tomorrow if I discover another two ways of writing the calculate function, then I'll keep adding it or making changes to this class itself, right? And it would make the quadratic class into a very complex class. Okay, the idea is to write the class in such a way that if any changes are required, we create an extension rather than going and making changes to the same class. Let's see how that would look like. So third method, I have the main class. This actually creates an instance of quadratic, which in turn is associated to a method, right, which is abstract, and this has an operation called, let's say, solve, right? And here the method is not specified. But what I do have is a separate class formula method, which actually contains the algorithm for solving the equation using formula, quadratic formula. And then I have factorization method, which also implements this solve method. Now the advantage of this is that every time a new method is discovered, I just have to add one more class. Yes, graphical method. So basically, I'm not going to make changes to this class. Changes to this quadratic class is very much restricted. And it's just a question of keep adding classes for every type of method that I discover. Let's see how this would look like at the code level. Okay, let's go here. Class roots. So for roots itself, I'm creating a separate class, and I'm going to be passing around this abstract class solver. This is our abstract class. public abstract root solve, class solver using formula, extends or inherits from solver, public override root solve, so it overrides the or basically provides the implementation for solve. This is another class, remember, solver using factorization, again inherits from solver, and here you have the implementation for that, and here you have quadratic. Yes, so here if you notice public roots calculate zeros and it is accepting a int parameter, and depending on which method has been chosen, it will instantiate the appropriate solver and call the solve operation. And here you have the main. Now I am sure you understand that looking at code and trying to understand it is very exhausting, right? So let me, although I have already shown that using diagram, let's actually create a model. So let's create a view. Let's say quadratic equation. Let's create a class diagram. So let's before that create a package without pattern, and let's say with pattern. Okay, without pattern, develop files, import source directory. Let's say quadratic solver. Okay, close. Straightforward. Main class. This creates an instance of this quadratic and calls these operations. Okay, now let's actually see how it would look like with the pattern applied, the strategy pattern applied. Okay, again develop files, import source directory. Let's go to pattern applied folder and say okay. Close. Now look at this. It doesn't actually organize it properly. Now just a question of moving it around. So let's bring this solver here, solver factorization method, main class, quadratic, and let's make this line style vertical, and the roots. Now let's understand what happens. What happens is this creates an instance of quadratic. This creates an instance of roots. Quadratic. Now there are multiple ways in which this could work. Here what I am doing is this creates an instance of solver, right? So the thing is main creates an instance of quadratic, calls accept details, but before calling anything here, it accepts from the user which method to use. Okay, then it creates an instance of this, calls accept details, then depending on which and it calls calculate zeros. Now this in the calculate zeros, depending on the value that the user has given, the appropriate instance of this is created and solve method is called. These initialize the roots after calculating them and return it to quadratic, which displays these roots. Okay, let's run this code and see quadratic. Now let's say quadratic method 275 minus 1 and minus 2.5. Okay, where did we do our calculations? Minus 1 and minus 2.5. Right, now let's run this again, but run the other using the pattern, and you might notice that uh, as far as execution is concerned, there is no difference, minus 1 and minus 2.5. But if you look at the diagrammatic representation of the pattern, if tomorrow I want to add one more method, what happens? It's just a question of adding one additional class, graphical method. And providing the implementation for solver, whatever it be. So this design simplifies the solution by allowing me to keep extending my design rather than making changes to existing classes. So what does this pattern actually say? This pattern defines a family of algorithms, encapsulates each one and makes them interchangeable. It lets the algorithm vary independently from clients that use it. Again, this can be done in different ways. It could happen that which method to use is stored in a registry entry or a configuration file. Main just calls these operations, calculate zeros. What the calculate zeros does is it reads that configuration file or the registry entry, gets a parameter, and based on that parameter it just creates an instance of this and calls solve. That is another way. Another way is which method to use. Anyhow, this is doing it, accepting from the user. Now what might happen is in main, depending on the user input, this gets created. This is passed to quadratic, calculate zeros, and this, using that reference, just calls solve. So this is another way in which this pattern can be applied. Okay, instead of me talking all this, we could have actually done a sequence diagram. Let's very quickly sequence diagram. So let's get this, let's remove this. Okay, execute quadratic and quadratic. So what happens is calls accept details, then depending on which method. So let's say calculate zeros method, a factorization method, and this in turn at some point in time calls common factor, and finally this calls display roots. Whereas the same thing here would be what? Quadratic, and as I mentioned, It could be different ways in which we can implement it. Execute quadratic. Okay, so this would create an instance of this. It would create, let's say, solver using factorization. Different implementations could be execute quadratic, calls quadratic, which in turn creates solver factorization. This in turn, so let me actually, it calls accept details. This calls, let's say, calculate zeros, and depending on the parameter it will create an instance of solve. And this would return the roots, and this will call the display. Strategy pattern. What does it say? Different algorithms take out and define it in its own hierarchy. Different ways. Parameter sent to quadratic and appropriate solver created. Client creates the solver and passes it to the quadratic. Which solver to use? Stored in config file or registry. So that's it. Bye for now.